Welcome to the EMG paired t-test video. We're going to actually start a little bit with the physiology for this section of the lab. Something to understand about slow twitch and fast twitch muscles is the fact that you have different types of muscle fibers that behave very differently. The most distinct extremes of that is the slow twitch muscle fibers and the fast twitch muscle fibers. The slow twitch muscle fibers having high blood supply but low force generation tend to be slower in the frequency of firing, meaning that they are more steady paced. They go at a certain kind of slower rhythm, if you will. The fast twitch muscle, on the other hand, are low vascularization, meaning they don't have that big blood supply, but they can generate a lot of force. And their pacing of firing frequency for the neuron motor unit combination is that they're going to be faster. Now, when you say, hey, how can we differentiate in an EMG signal the difference between this fast twitch and slow twitch muscles? And that is when we get into the median frequency. So a bit of a primer in the frequency domain. The frequency domain is the combination of all possible frequency components of a signal. We're going to be throughout the class talking more about it, so you'll become more familiar. But the thing that you have to roughly understand is that for slow twitch muscles, our expectation is that the median frequency, meaning the center point of the area under the curve, is going to be towards the lower frequencies compared to the fast twitch, which is going to be roughly at a higher frequency. Now, why do we look at the median frequency rather than at any other particular aspect of the frequency domain? And the reason is that these EMG signals are very complicated, and it's easier to just look at the overall shape of the EMG signal and where they land versus having to look at specific features. Now for the post lab, you will have to complete this table. You'll have the dominant hand, high, medium frequency. You're going to have 30 samples. And for the non-dominant hand, low, medium frequency, you're going to have 30 samples. Once you go ahead and fill that table, you can pass it into Excel. I love Excel, so that's what I use. So you can go ahead, copy and paste, and then simply come here and again, paste with variables. Now, there are some other types of analysis that we're going to be performing, but honestly, my biggest question regarding this particular data set is to determine whether can I differentiate between the firing frequencies and the engagement of these two muscles. I have a dominant hand and I have a non-dominant hand, and I have a low weight and a high weight, and I just want to see, hey, can I tell these apart? So what you're going to go ahead and do is analyze, compare means. Now, this is something that we need to think about a little bit because it is not a one sample t-test because we have two samples, we have two little bags, but it is also not an independent sample t-test because these two bags that we have of data are related to each other. So we have to run a paired sample t-test. Our first variable is going to be this non-dominant. I don't know why SPSS copied the names so quirkily, but we're just going to go ahead with that and say we have the non-dominant and we have the dominant. Let me double check which one is which. So, I actually named them both non-dominant, so that's why it was giving me an issue. So we'll just change the first one to dominant. So we know the first one is dominant and the second one. For options, I'll go check here, confidence intervals, nothing that I need to change. I do want it to estimate the effect size, so I'll just go ahead and run it, and then I'll see. First thing I want to see is just this standard deviation, standard error mean, just basically where there are. I can see that the dominant is the first one, the non-dominant is the second one. The first one is a little bit higher than the second one, so that's fine. It means that probably there's more engagement of faster frequency in the dominant hand than the non-dominant hand. And I see that the standard deviation is roughly the same, so it means that there's no outliers. The ranges of the values are somewhat comparable. Now, for the paired sample t-test, I just want to see, hey, what is the difference? Is there a difference? Is there significantly difference between these two particular data sets? And it happens to be that yes, in this case, I don't know if they're going to be higher or lower than each other, so I'm going to pick the two-sided p-value. A little bit of a refresher between the one-sided and the two-sided. One-sided is if I have an inclination of one is going to be higher or lower than the other one, whereas two-sided is it could either be higher or lower. So the difference could be above or below zero. So in this particular case, we're going to conclude that for this paired t-test, the dominant and non-dominant hand were statistically significantly different from each other with a p-value of less than 0.001. As far as this part of the post-lab, that is the only thing I need. I just need this paired sample statistic table and this paired sample test table over here. And then that will be it. If you have any questions, of course, don't hesitate to reach out and ask any of the instructional team.